So today let's look into correlation versus causation. So this is one of the famous concepts you will come across in machine learning, right? What is correlation? And if two features are correlated, people might say correlation doesn't mean there is causation, right? So let's dig deep on what correlation is. And also let's look into some funny examples to better understand correlation. And also we'll provide some brief examples about causation and what is causation. Let's check it out. So why we need correlation and causation, right? So let's say you have two features basically, right? Hours of study and marks in exam. Now it this is you have just six records here, six students you may consider. So one student has studied for 1 hour and he or she has got 40 out of 100. And you see, there is a pattern here, right? So as the hours of study keeps increasing, the marks in the exam is also increasing, right? So if you take correlation against hours of study and marks in exam, you are supposed to get a very high correlation, right? Meaning one feature is enough to convey the information about the other feature, right? Both the features are going in the same direction. So as you increase hours of study, marks in exam also increases. So that is the insight that correlation says. Okay, so that is what we observe from correlation. So let's look into this feature in terms of causation. What does causation say about these two features? Causation could say, right, whether hours of study truly influences marks in exam or not, right? So this is what is critical here, right? So cause correlation doesn't give you that information, but hours of study it says it nails that actual cause of marks in exam is due to hours of study, right? One of the cause to get a higher mark is hours of study, right? If you consider marks in exam as the target and hours of study as an influential feature, then causation can tell you whether or not hours of study is the cause of marks in exam or not. Right? Okay. So let's look into how to mathematically derive correlation. Right? So again, looking into the same data set, right? So mathematically, you can derive correlation, Pearson's correlation, using this formula. So what it says, so to calculate correlation, you need mean of the feature. So here x bar is nothing but the mean of hours of study, any feature, right? So we are trying to compute correlation against two different features here, hours of study and marks in exam. So x becomes your hours of study and marks in exam becomes y. So mean of x is nothing but the average of hours of study. Okay? And mean of y is nothing but the average of marks in exam. Using these two as the inputs, you can derive the correlation of these two features. Right. So let's look into uh, a Python code on how to execute this. Right. So I just created the NumPy array out of these two features. Okay. Now in NumPy you have this function called correlation coefficient, and if you run this code, this should print the correlation computed. And I already ran it, and the correlation was almost 99 percentage, right? I should not say percentage, it's 0.99, which indicates the strength of a relationship between these two features, hours of study and marks of exam, is very high. Okay, yeah. And on a funnier note, see that is this website you can look into. Like you can find correlation between two different features which are not even related to each other, right? At least we may not know the relationship, but it looks funnier. Like for example, if you check the correlation of degrees awarded versus search volume, right, on zombies, right? So you would see this is there is a very high correlation between number of times the word zombies has been used to search in Google versus degrees awarded. So you see the clear correlation, right? That most the curve, the two trend is almost similar to each other, right? This may look funny, right? How and what way degrees awarded is related to the Google search of zombies. But if you consider correlation, correlation can show a higher strength between these two features. Right? So, like this, you can find many other examples here, right, in this website. I'll add this in the comments. Now, let's look into causation. So, causation, on the other hand, it provides a confirmation that one feature is the cause of the target, right? So it will give you an idea, right? So it's not saying both the relationship between both two features are good or not good. So it's not uh, going in that direction, but it says the cause of the target is due to this feature, right? So it gives you that information, and that is very very concrete, right? You can trust that info, and you might have come across things like smoking causes cancer, exercise can be used to relieve stress. So these are based on causal analysis. Okay? These are not correlation based. Maybe they both of them might have high correlation, exercise and stress, or smoking causes cancer. So both might have all high correlation, but only with the help of causation you can confirm the hypothesis, right? So even in this data set, what if hours of study is not the cause? Maybe marks in the exam is also related to multiple other factors. How good the material of the student is referred, right? How good the student has a background in the subject, right? How's the environment he studies, right? It should be maybe a cleaner environment or a pleasant environment. So that could be multiple other causes for the student to get high marks in the exam, right? So causation will give you an overall perspective, right? So that is what is concrete compared to correlation. Yeah. And there are few more examples you can relate to, right? So if you consider the correlation of ice cream sales versus sunburns, so sunburns are nothing but uh, people get it the skin irritation, right? Over exposure to sun can cause skin irritations, so that is called as sunburns, and these two are highly correlated, right? This may not look so related to each other. Again, as we saw in the example, right, in the website, those funny examples that can happen. If you just consider correlation, this can happen. But if you are going to consider the causation, right? But the causation says the hot weather is the main cause for both these, right? So hot weather can cause sunburn, and the hot weather can also cause high ice cream sales, right? So this is a confounding factor. So if you are not considering this feature, hot weather, you may not able to derive a relationship between sales and sunburns. So same example can also be applied to here as well, right? Sales of umbrella during monsoon versus fried snacks, pakora, we call it in India, right? So this is almost follows the same pattern as we observed in the last example. I just wanted to share this because this is one of the commonly used concepts, correlation and causation. Whenever two features are, to summarize, right? Whenever you say two features are highly correlated, that does not imply causation, right? You may need to do few more experiments, causation related experiments to confirm that. Uh, just wanted to finish on that note. Thank you. If you like this video, please subscribe, give a thumbs up, and if you think it may be useful to others, please share it with them. Thank you. Bye.